Okay, let's spend whatever looks for class in talking about switches. So, what do the switches do? Open and close the circuit.
Or on and off.
And why do we have different variety of them? There are different switches. We have different functions for those switches. What do we need? So, these ones are the simplest switches, which is on and off. So, you manually turn them on and off. It's very simple, very done. But think about an AC. If you had all the switches, all the circuits by hand on and off, somebody has to be there to turn on the fan, to turn on the compressor, and wait there until temperature gets the right temperature, then turn it off and on. So this automation. And that's why we have different kind of switches. But for on and off, we have these switches that can be turned on and off manually. What about toggle switches?
Toggle switches?
Yeah, when you push them, then they get deactivated by themselves. They're basically a small relay. There's a magnet in there. You engage it. Then once the condition is achieved, it will disengage. For example, if you go into an elevator and you press the floor button, it lights up. You engage the circuit. A corresponding circuit in the same floor will trigger that motor to disengage. So if you look at the boards, all the elevators, of course, they are full of relays. You engage the relay, it will turn on the motor, it will stop once you reach the floor. In the same place, they have a magnet that will disengage. Of course, they have a lot of safety devices, so it will not keep going. But that's a toggle switch. You engage it. Once the condition is met, another circuit will deactivate the circuit. So on and off or toggle switches. So if you look at this switch in here, it does not engage. You just hit it once and something happened inside.
That's a toggle
Yeah.
switch.
That's a push button. You just push it and it will do something. And every time you can push and hold, you can push. But some of them you just push and it will engage it, push again, it will disengage the circuit on and off. They could be mechanical and they could be or they could be electrical. What other switch do we have? Come on. Disconnect switch. What's a disconnect switch? Disconnect switch, what does it do?
Connects to the main power supply.
Yes. Disconnect switch goes to the emergency, goes to the main power, and the whole thing is dead. By NEC, we have to have a disconnect switch near every equipment. If the equipment is outside, you'll have the switch outside. If you install a mini split and the unit is outside, they have to have a disconnect switch next to it. Why? Makes sense.
Yeah.
If it catches on fire, it's making a loud noise, you want to be near it and disconnect instead of running all the way to the basement and trying to find it. It should be visible. Push button switches open and close a set of contacts by pressing a button once. Thermostat is also a switch. It turns on and off based on either mechanical linkage or electronic command. What do we use to control, to sense if we have no mechanical linkage? So the mechanical linkage will expand and contract, right? It's a coil. What else do we use to measure temperature that we used in the lab last week? What is the thing called? Thermocouple.
There.
So this one has a thermocouple. What does thermocouple do? It sends not temperature, you read a temperature, but it sends voltage. Millivolt, very small voltage. Once it gets heated, it will send voltage. And you saw how when you touch the wire, you made heat and the temperature goes up, that the voltage has increased. This is how thermostat works. There are mechanical thermostat, which is basically bimetal. How does bimetal work? Let's look at it. Even though they're not used in homes anymore, they are still functioning somewhere. So let's look at this thermostat. It's an old thermostat. And if you look at the spring inside, I'm gonna pass it around. If you look at the spring inside, you notice how it's very long, it's very thin. So when this thermostat heats up, the coil will expand and start to hit the switch on the top here. So it expands and contracts. Why did some of those thermostat had mercury inside, mercury bulb? So this one has a magnet. So when it expands, it will approach very, very slowly. And what happens to the voltage when it gets very close to air? It will cause a small little spark, and we don't want that spark. That's why they have a magnet. Once you get close within range, it will snap it back. We have also a bulb full of mercury, because mercury is conductive. So once it tips, it's gonna come and connect. Because we're trying to avoid that little spark. Mercury has been banned in bulb, but it bursts, it will produce a lot of vapor. So we have these metallic bimetal where it will snap in action and connect the switch. So thermostat mechanically connect or disconnect voltage. They can be a cooling thermostat or a heating thermostat. What does that mean? What's a cooling thermostat? It turns on the AC. When it gets too hot, it will connect the circuit for the AC. A heating thermostat, when it gets too cold, it will shrink and connect another circuit. So let's look at it. There's an easy way to think about it. So is this a cooling thermostat or a heating thermostat?
Cooling.
What's it cooling? Yeah,
I did.
because
You just said it.
this will increase when it gets hot. It will go up and connect a circuit that's going to be a cooling thermostat. What about this one? It's going to be the opposite, of course. When it gets cold, it will shrink, it will contract and connect the circuit, and it will be a heating. Heating thermostat, cooling. Heating thermostat, cooling thermostat. And we had the same thing for high pressure cutoff, low pressure cutoff. We use also mechanical.
Question for you.
Yeah.
I know in one of our homeworks for one of Bill's classes, it said something about you couldn't adjust the heating delay or something, or the
Yeah.
differential in that. Is that why? Because you mechanically can't move it that far.
That's one of the things, one of the reasons, yeah.
Okay.
Because if you think about the delay, you're
Yeah,
right.
You can move that anyway.
This is a spring. The spring K factor, or the expansion rate, is calculated, already preset. So it's the way it is. You have to change the entire spring. And you guessed it now, after a long, long period of time, what happened to the spring? Maybe. It's gonna get weaker. Springs always get weaker, right? Your car has springs, right? After a few years, when the mileage, you have to change those springs, they get weaker. Because you are fatiguing them by going back and forth all the time. And you see this little spring is very thin. Over time, it will have misreading. You have to do a realignment for that. Pressure switches, they do the same thing. They either open at heat or open at cold. So if it's high pressure, it will cut off the circuit on low pressure. So for us, we have either cool temperature and pressure. That's what we are trying to sense. The new mini splits or ACs, they also have humidity sensors. So same thing, it will measure humidity, and based on that, we'll open a link to water. So either add moisture to the duct or try to run the dryer. Okay, questions about thermostat and switches? Manual switches, remote switches, toggle switches, on and off, relays, those are all switches. So when you think of switch, think of something that make or break the circuit. Either we make circuit or break a circuit, and we get a belt on it. So one switch will open, to close another switch, or might open another two. So you'll see that. And this will become very, very visible when you work with the primary control, because this has a lot of decision making when it comes to burners. It will see the flame. Once it sees the flames, it will cut off the oil, it will cut off the ignition, and engage something else. So it basically few relays in here that are getting smaller and smaller. Okay, I think that's enough. I'm done for today.